So let's keep going. So now we have Rutherford's conclusions, but so now Rutherford gets to propose his model. So his model is called the nuclear model. Okay? So what he says, what he ends up finding out is that the atom contains a tiny, dense center, and he's going to call that tiny, dense center, he's going to call that the nucleus. That's where we get the nuclear model name from. And to kind of give you an idea of how tiny this is, this nucleus takes 1/10 trillionth the volume of the atom. I've heard someone describe it before, or I think I read it in a book. This would be like if you had a grain of rice, just one little grain of rice on the 50-yard line in the middle of a football field, and then the entire atom was the whole stadium. So this is kind of how you can think about the nucleus would be the grain of rice, and then the whole stadium would be the atom. Still not quite this, but it kind of gives you a little bit of something to think about. All right, let's talk about the mass. The nucleus has essentially the entire mass of the atom. Because remember, right now the atom has the nucleus and electrons. Electrons are really, 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 really small and light. And the nucleus is going to weigh a lot more. So the mass is going to come mainly from the nucleus. So think about having like the mass of a whole bucket of water compared to a drop of water. Okay, so the mass the drop of water has is kind of like you're going to ignore it compared to the whole bucket's mass. The nucleus is positively charged. And here he's going to say that it's positively charged and that the amount of charge here is going to balance out the negative charge. So we're going to have a balance of charge. Also, so his nucleus isn't just one thing. The nucleus is made out of other little particles. And so these other little particles are positively charged, and these are called protons. And so this is your second subatomic particle. So we have electrons and we have protons. So the nucleus is just a bunch of protons. A bunch of protons in the nucleus, compacted there together. They're positively charged, and they got some mass to them compared to the electrons. Okay? So if I asked you who discovered the protons, it's Rutherford. Who discovered the electrons? J.J. Thomson. Okay? And I'll give you the details on the protons in a little bit. All right? So, and the model is that the electrons are dispersed in the empty space of the atom surrounding the nucleus. So that's what this structure looks like. So if we look at this picture, you have my nucleus, which has my positively charged protons, and you have my electrons, two subatomic particles. That's what Rutherford's nuclear atom looks like. So let's see if that makes sense. While I was talking, you might have thought of something in particular that you're like, wait, something doesn't seem right here, okay? How is this going to happen? So there are some problems with his model, and you might have thought of some of them by yourself. So one of them is, say for example, we have beryllium. Beryllium has 4 protons. So if I have 4 protons, they're in the nucleus. Remember, the volume is small, so they're compacted into the nucleus. And if they're positively charged, what is one positive going to do? Repel. So if I've got 4 protons that are stuck in the nucleus, why don't they repel? What's preventing them from repelling? What's keeping them there? The other thing that Rutherford noticed was that if the beryllium atom has 4 protons, and the protons are the thing that has the weight, so say 4 atomic mass units, then my beryllium atom should just weigh 4. Because if the only thing I have in there is protons and electrons don't weigh that much, then my atom should just be 4. But my beryllium atom actually weighs 9. So I'm missing 5 AMUs. I'm missing some extra mass. So there's got to be something else in this nucleus. So something else that keeps the protons from repelling, keeps them there, and has to have some mass. So this is where Rutherford comes up with the 3rd subatomic particle, sorry. And this is my neutron. So now we have all 3. Electron was J.J. Thomson. Rutherford, he gets the proton and the neutron. So he says there's got to be a neutron. The neutron is going to have neutral charge, no charge, and it's also going to have mass, because remember we're missing that mass. So it has a mass of 1 AMU. So this is the exact mass if we want to put it in gram units versus AMUs. So it's slightly heavier than a proton, but we kind of think about them as comparable. It's a little bit heavier, but close to about the same, and no charge. Okay? So what happens is in my nucleus, the neutrons kind of get in between the protons. So here's a proton, here's a neutron, here's a proton. And that's what keeps those protons there. Because there's space, there's kind of a guy kind of keeping the peace. Saying, okay, you're positive, but you're far enough apart that you should be able to chill out and just hang out in here. Okay? So that's what keeps the protons from repelling. And then where my extra mass comes from is from these guys. So I kind of have a summary table for you of your 3 subatomic particles. So here are the 3 subatomic particles. You need to know them. You need to know it's a proton, an electron, and a neutron. You don't have to know these exact numbers. But you need to know that the proton and the neutron are about the same mass, and the electron is really small. You need to know where they're located. The proton and the neutron are in the nucleus. The electron is in the empty space around the nucleus. The proton is a positive charge. The electron is a negative charge. And the neutron is 0 or neutral. And then this is how we could write it. So if I'm writing like 12 protons, I might write 12p, 12p plus, or H plus. And we'll talk about what H plus means when we talk about acids more, especially next semester. Okay? Electrons, you might see E or E to the negative, or N to the 0 for neutrons. So pretty much you need to know this entire chart. You don't need to know these numbers exactly, but you need to know how they relate. Now, you might be saying, okay, is this what our current model of the atom looks like? So it isn't exactly like, It isn't exactly like this picture. When we get to the later chapter, we're going to talk about exactly where these electrons are. But this is pretty close, okay? So nucleus is in the middle, you've got your protons, your neutrons, and your electrons are around. All we have to talk about now to kind of get a little bit more detailed in our nuclear atom model is where are these electrons? Are they anywhere, or do they have a specific place they could be? And they have a specific place. But this is a good general model, okay? So as far as being general, it's correct. All right, so that is our kind of our little whirlwind of history for the atom. So now that we know what an atom is made out of, those subatomic particles, protons, neutrons, and electrons, now we're going to say, okay, we took the atom, an element has atoms, and we went down. Now if an element is contained of atoms, let's talk about an element now. Now that we know what the atoms are all made out of, let's talk about what an element is and how is it compared to other elements. So that will be in our next lecture.